Hello everyone, this is Jason. Elon Musk has just dropped a bombshell. Tesla and SpaceX are reportedly joining forces to build Terafab. This is not just another chip factory. It is being described as a monster system capable of producing 1 terawatt of compute per year. The idea is even more radical than that. A huge share of that compute could be deployed in space, making AI power as abundant and as cheap as solar energy. If this vision becomes real, it would mean taking AI out of earthbound limits and pushing civilization one step closer to an interstellar future. Do not miss today's episode. Let us get into it. Let us start with Terafab. Over the weekend, Elon Musk appeared to unveil what sounds like a major joint move between Tesla and SpaceX. And this is why people are so shocked. This is not simply about opening a new semiconductor plant. The bigger picture is about building an AI infrastructure that can extend beyond Earth itself. SpaceX has shown a mini AI satellite concept, and the scale compared with Starship immediately raises the question of cooling. Elon says SpaceX understands thermal control in space very well. He described the current version as around 100 kilowatts, with future systems expected to reach the megawatt level. According to this vision, the satellite would use Tesla's D3 or Dojo 3 chip, optimized for space. It could run hotter, rely on lighter radiators, and fit into a much more ambitious orbital compute network. Elon also said the core of this plan would start at Giga Texas, where an advanced technology fab would be launched. In his words, the goal is to place every key chip-making step inside one building. That means mass making, chip fabrication, chip testing, and then quickly creating new masks again. The point is an ultra-fast feedback loop that improves design far faster than the fragmented model used across the industry today. It argues that the world's current chip output growth of roughly 20% per year simply cannot keep up with demand from Optimus, XAI training, and SpaceX systems like Starlink. His answer is Terafab, which he describes as 2 highly specialized fabs, each focused on only one chip design. That simplification, in theory, could unlock huge production scale and push annual compute toward 1 terawatt. One chip would serve Tesla on Earth, while another would be a space-optimized D3 for SpaceX AI satellites. The proposed scale sounds almost absurd, with talk of 100 million square feet, many times the size of today's giant factories. Elon also believes that within 2 to 3 years, deploying AI in space could become cheaper than deploying it on Earth. His argument is simple. Space has constant solar energy, no atmosphere, and no night cycle in the same way ground infrastructure does. SpaceX also showed footage tied to a lunar electromagnetic mass driver concept, suggesting that large AI satellites could one day be launched into orbit from the moon using Tesla chips. Elon even joked about going beyond the moon and Mars. Whether that sounds visionary or outrageous, it clearly shows the scale of his ambition. Still, the risks are enormous, including massive power demand, land use, and costs that could run into tens of billions of dollars. Now let us move to the second part, the rising pressure on Optimus from China. A recent report says Unitree has filed for an IPO on the Shanghai Exchange, aiming to raise around 4.2 billion RMB, or about $610 million US. In 2025, the company reportedly shipped more than 5,500 G1 humanoid robots. Revenue is said to have reached around 1.7 billion RMB, with gross margin above 60%. That would make Unitree the first company in this category to achieve both scale and profitability. More importantly, it gives the public market a real valuation reference point for the humanoid robotics sector. Unitree's G1 gained traction partly because of its lower price, and reports claim it reached the top position globally in shipments with more than 32% market share. The company is already using robots in real assembly tasks while maintaining strong margins. That sounds impressive, but it does not automatically make Unitree the final winner. This industry is still in its infancy. Most robots today are still handling basic tasks like inspection, guiding people, or simple demonstrations. The real prize is not selling a machine that performs one narrow function. The real prize is building a general-purpose robot that can adapt flexibly and perform many kinds of work. Future Tesla Optimus and Figure are trying to reach with advanced AI. At the same, China's progress cannot be ignored. In costs, manufacturing, and delivery scale, Chinese firms clearly have momentum. One example is LinkerBot and its LinkerHand L30 from Beijing Lingxin Chaoshou. The product has been described as having extremely fast rotation and highly precise fingertip control. Once robotic hands begin exceeding human anatomical limits, they stop being simple tools and become force multipliers for productivity. This shows how hard Chinese companies are pushing on hardware detail, and that brings us to a deeper debate in robotics itself. The biggest criticism of humanoid robots is not about nationalism, it is about whether the entire category is being overhyped. That criticism has been voiced strongly by MIT professor Rodney Brooks, often called one of the founding figures of modern robotics. His argument is straightforward. Why obsess over a human shape in every case? He offers three challenges. First, robots should be designed around tasks, not appearance. A forklift is far more efficient than a humanoid for moving loads, and an autonomous mower works better than a two-legged machine for cutting grass. Second, bipedal walking consumes enormous resources just to avoid falling over, rather than helping complete useful work. Third, overpromising can become self-deception. Brooks has used tying shoelaces as a simple example of something robots may still struggle with for decades because touch feedback and force control remain so difficult. That view is not an insult aimed at one country. It is a challenge to the direction of the whole industry, and it deserves serious thought. Tesla, meanwhile, has not yet reached large-scale Optimus deliveries, but its strengths are different. Tesla has end-to-end AI learning, gigafactory-scale manufacturing, and Musk's habit of making long-term bets before the numbers look obvious. Even if Tesla is behind in production today, Musk is betting on the AI brain that could matter most 10 years from now. TSMC chairman C.C. Wei recently made a similar point, saying flashy robot movements are not the real issue. The real key is the brain chip, and most of those are still made by TSMC bold projects today. C.C. Wei recently made a similar point, saying flashy robot movements are not the real issue. The real key is the brain chip, and most of those are still made by TSMC. So it is far too early to declare a winner. Unitree has given the market the first real benchmark for profitable humanoid robotics. China does appear ahead in some areas of hardware scale, but Tesla's approach of treating AI as the true core of the machine may end up determining who really changes the world. And that is the bigger lesson here. When someone proposes a radical idea, most people laugh first. When early success appears, they often respond with ridicule or labels. And when real success finally arrives, many people try to dilute the credit or hand it to someone else. Musk's point is that people who change the world are often treated like jokes before they are proven right. Thanks for watching. This is Jason. Please like, subscribe, and share your thoughts in the comments.